Good morning and welcome to yet another Micrographics webinar. Today we are going to be covering Inventor Professional and large assembly management within Inventor Professional. I'm your host, Carl van Rooyen. I'm an application engineer with Micrographics, and I'll be taking you through how we handle large assemblies within Inventor Professional. Please feel free to use the live chat to post up any questions, say hello, let us know where you're from, and we can acknowledge that. And if there are any questions, you can place them there and we can answer them either throughout the course of the webinar or at the end. We are going to have a Q&A session as well. This webinar is being recorded and it will be posted up on our YouTube channel, Micrographics SA. So if you do want to review it at a later stage or want to catch up on something, then it will be available there. So on today's agenda, we will go through our introduction where we will introduce two scenarios with regards to assemblies in Inventor. And then we'll go through the tools that allow us to work with large assemblies and make changes to large assemblies to help with the scenarios that we'll cover in the introduction. So those tools are Express Mode, Model States, Simplify, and Substitutes. And we will then close off the webinar with a summary and a Q&A session. So for our introduction, we're going to first talk about what constitutes a large assembly. Now, with the experience that I've got within industry, I've found out that the term large assembly is very relative. I talk to some customers and they say 500 components is large. I talk to other customers and they may say the 5,000 or 25,000 components is a large assembly. And I'm pretty sure we've got customers at Micrographics that laugh at 25,000 and say that's probably small. So large assemblies is a very relative term. I suppose it depends on what you have been exposed to in your design environment. But typically we would look at either complex machines, as we see on the right-hand side here. We have a complex machine made up of many parts. And we have also this jet engine, even more complex, made up of even more components. So large assemblies could be complex machines. They could also be 3D factory or site layouts. And we can then build from there, have multiple factories that need to be laid out next to each other. And so depending on your industry, you would be working with different types of assemblies, but at the end of the day, your final product could be quite a large assembly. And so for today, what we're going to consider as a large assembly is something that's going to require most of your computer resources, most of your PC's resources. And there's sort of two areas which get impacted by large assemblies. The first is your RAM. Whenever you load up your assemblies, then those components within those assemblies and the assemblies themselves are loaded into RAM. So you might see that when you're running idle, you may only have 4 gigs, 5 gigs of RAM in use. But as soon as you open your assembly, that RAM that is in use will then spike. Depending on the size and of the assembly, how many components there are, that will determine how much RAM is used up. And of course, if you have multiple large assemblies open, that's going to start filling up. The other area is VRAM, essentially the RAM on your graphics card. You'll find that some graphics cards may only have 2 gigs of RAM, and when you rotate your view, you'll find there's a bit of a lag. You've got to wait a while, and then eventually the view updates, and components might disappear and slowly render back into your assembly. And so you start to hit a wall with regards to the capabilities of the PC. And so we'll take that as our consideration for large assemblies. And what we're going to do there is we're going to say, okay, well, we've got these large assemblies, and there's two areas in which we need to look specifically, or we'll look specifically at these. And that is, how do we protect intellectual property for when we share these assemblies with other companies, with other individuals. And then going back to the computer resources, how do we reduce the load on your computer while you're working with this large assembly on a day-to-day basis? So in our introduction, we're going to look at those two scenarios, and then we'll look at the tools in which we can use to both protect intellectual property, but also reduce the load required on your computer to work with these large assemblies. So the first thing we'll look at here is how do we protect intellectual property, or how do you as a designer protect intellectual property? Because you may need to share your model. And I've got a bit of a scenario here to explain the situation, or to explain why you would want to do it. If we look at the wind turbine on the right-hand side of the screen, we've got detail inside of there with regards to things like the gearing, the generator that's in there. There may be control systems within that model, electronics. There's a lot of detail with regards to nuts and bolts and flanges and the actual construction of that wind turbine. So if you are the company that owns the design of the wind turbine, you own the patents linked to that wind turbine, you may be approached by an energy company that wants to set up a wind farm. And they want the model so that they can do spatial planning on the wind farm. Where are they going to place these wind turbines? Make sure the clearance between them, make sure they are set up correctly. So you want to be able to share that model with them. You definitely want to make the sales and sell 100 of these wind turbines. But you don't want to give them the full model. You don't want to give away your IP. And they definitely don't want to have a fully detailed, heavy model where they are going to place, let's say, 100 of them in a field. And that would slow their design process down. So you want to create a lightweight model. And we're going to look at some of the tools that allow us to do this, where we can remove features. If we look on the wind turbine, the column sections have flanges with bolted flanges on them with a lot of detail. You'll have the nut, the bolt, the washers, the actual flange, and any holes within that flange. So details like that are not going to impact the overall layout of the wind farm. So things like that, those features can be removed. We can look at filling voids. If we look at the turbine blade itself, it may be hollow with internal strengthening structures inside of that blade. And you may want to reduce the complexity of the modeling requirements on the PC. So you can fill those voids, make those turbine blades solid. In a way, you're also protecting intellectual property with the types of support structures within the blade. And going on to removing that intellectual property, we would look at removing any unnecessary parts within the turbine that are not required for spatial planning. There could be things like gears and shafts, internal components, that entire internal assembly can be removed. And especially specialized equipment where you may hold patents for, and you don't want other people copying those designs. And so that would allow you to strip out the model and share that on. So that would be the first scenario that we may need to simplify down or reduce down complex assemblies. The second scenario, which is the more urgent day-to-day scenario, is the reduction of the load on your PC. So you may work with assemblies that have high part counts or that have complex part geometry. And both of those would have an impact on the amount of resources required for you to run your design process on a day-to-day basis. This one machine here in the image may be one portion of an entire complex assembly line. But this machine on its own has about 7,500 components in it. But you may have multiple production lines with multiple sub-assemblies or machines within that production line, and your part count can quickly climb. So we'll look at the different tools in which we can both protect intellectual property, but also reduce the complexity of the designs. And those tools that we're going to be looking at are the express mode options when opening up large assemblies, We'll look at model states, both at part level and assembly level. And we are also going to look at the simplify option to be able to simplify down either parts or assemblies, as well as creating substitutes, where we can substitute out a single part file to represent an entire assembly. So starting off here with Express mode, what Express mode does is it loads a limited assembly, limited graphics and functionality assembly. By default, Inventor is set to load in Express mode if your assembly has more than 500 parts. So Autodesk's baseline for a large assembly is essentially 500 parts. So what happens here is when you open up your assembly, Inventor checks, okay, it's greater than 500, will load into Express mode, and it opens the assembly quicker. But it does open with a reduced graphics integrity, but also reduced functionality. So it opens it quicker. It allows you to open large assemblies quickly, let's say, show a manager something if he has a question. You don't have to wait for the full assembly to load. The navigation, so orbiting your model and navigating your model, is smoother due to that reduced graphics quality. But as I said, we get that poorer quality display. And then you're also reduced in your functionality within the assembly. Now I've got there the load full icon. I'll show you what that looks like inside of, or where that is in Inventor once you load in Express mode. And also below that, we see the Express mode settings. You can see there, open in Express mode when the unique files exceeds 500. You can set that default option to open full. So every assembly will open full when you open it. Now on the right hand side here, I've got components in an assembly that is opened in Express mode. We can see that the circular components within this assembly are tessellated. They are straight edges rather than a nice smooth curve, especially if we look at the handle on the left hand side of that gearbox, as well as the grille on the motor. Now I'm going to switch to the next image, which is loaded in full, and you will see that the display is a lot smoother. We actually have a round grille and a round handle rather than this tessellated shape. I'm going to cycle back one more time just so we can see the poorer display, and then when it's loaded full, we've got the much smoother display for that. So your Express mode, essentially just when opening up assemblies, improves the opening time. If you do need to work within the assembly and have all your functionality, you would click load full, and it would then take the extra time to load the complete assembly with all of the functionality. From Express mode, we move on to model states at part level. What model states allows you to do is it allows you to create various states that can represent various levels of detail within a part file. Just as a quick, let's say, definition for model states, if I want to expand that a little bit for those of you watching that have not worked with model states has essentially allowed you to create configurable parts. You can have 4 or 5 different states, and in each state you have different features active, maybe different parameters that have changed from state to state. But in this case, what we're looking at is using model states to be able to simplify the components down. So model states allows you to create various states, which within those states you can suppress features. If we look at these 3 images, the middle one, all the fillets and chamfers and holes have been suppressed and removed out of the design. The housing was shelled, the shell feature has been suppressed. And lastly, the third image, one on the far right hand side, there is a state where simplified geometry has been added. So 2 extrusions, one for a box, one for a cylinder, which define our envelopes. This was manually done in this example, but later on we will also see how we can automatically define envelopes. So model states at part level allows you to suppress features and turn off detail within the design. We will be going through a demo of these features as well. We will just have a look at the assembly level model states, and then I think we will be moving into a demo covering express mode and states. But if we have a look here now on the next slide, we can also work with assembly level model states. And so at assembly level, we can use the model states to remove components, either by suppressing the actual component itself or suppressing patterns that generate multiple components. So if we have a look here from the left to the right hand side image there may be, we can't really see it here, but there are internal components that have been suppressed within the design. But at the same time, there are states that are linked. So the original assembly has 3 states: fine, medium, coarse, and those states are linked to states within each of the components. Each component has a fine, medium, and coarse state. So we see the assembly, when it's put into the medium or coarse state, the components also change. So we see there on the second image on the right hand side, the gearbox housing has reduced in the number of fillets and chamfers. The detail has been reduced. And then in the coarse state, pretty much all the detail has been removed, and it's a very simplified shape there. So model states in your assembly can allow you to remove components, but also update the active state of the components within the assembly. So moving on to the demo here, I'm going to switch back to Inventor, and we see here in Inventor I have an assembly open. This assembly is roughly 7,500 components, but we've got about 876 unique components within this assembly, so we have a lot of duplicates. And if I zoom in, you'll see those duplicates are mostly going to be nuts, bolts, washers. We can see here on the plate quite a lot of cap screws that are repeated there. But the browsing through the navigation of this assembly is quite smooth. But if we zoom in and we look at the detail, let me go ahead and switch on the visual style shaded with edges. We can see that the edges are quite rough. And so this is the express mode that has been loaded. And my laptop there, I'm just rendering in some of the edges. But we'll see that in express mode, we get this load full option on the express panel. And if we go across to, I'm on the view tab at the moment, if we go across object visibility, center of gravity, those options are all grayed out here, as well as ray tracing. On the assemble side, we've got most of our options available to us. We can do joints and constraints. We'll see that simplify is not available. And on the design tab, none of the design accelerators are available to us. So in express mode, you have that limited functionality, but for large assemblies, you have quite smooth navigation. Now, this assembly isn't really pushing my laptop to the limit, so we won't see a huge difference between express and full, but if I do click load full here, you will see that it tells you loading full, and it will then load up the fully functional assembly. It didn't take very long to load up the assembly, but if we zoom in here, and I see in this case now, I probably need to update my graphics settings, but actually there we go. The grills here, they are being rendered a lot smoother now, and the handle, we can see the handle is also being rendered a lot smoother. So we're getting much better graphics on the renders, and in this case this assembly isn't really pushing the limits of my laptop, so the browsing is still quite smooth. But now that we have the assembly loaded full, we now have the ability to do or to use the design accelerators. If we go back to the View tab, we now have the options for object visibility, center of gravity. So we have that full functionality back on the fully loaded assembly. So just moving away from that, going into the model simplification, I want to have a look at the model states. As I spoke about during the, as I spoke about during the presentation, we have the three different model states that are created. And each model state here essentially has been predefined in this model, and we will see that as we cycle through the model states, different features within the browser are being suppressed and they're being removed from the model itself. So we see here in the medium state, a lot of the fillets, the shell, to turn this into a hollow component. If I go back to fine, we can see the hollow on the inside. Go to medium, all the holes on the sides, all the bolt patterns. They are being removed or suppressed from the design. And if we go to coarse, right at the bottom here, there are two extrusions that are being unsuppressed to give us the envelope of the gearbox. And so in each state here, you are able to suppress or change parameters to update the model. So in this case, we have, let's say, the medium, which still gives us the overall shape of the object, but it reduces the complexity down. Moving across to assembly states, what we will see, let me have a look at this part first as well. This is the handle or a lever within the assembly. You will see it also has those three states, fine, medium, and coarse. And activating each state, we will see that there are some direct edits made that are suppressed or unsuppressed as each state is changed and the geometry is updated. So we can simplify that geometry down in each state. Now going to the assembly, in the assembly we see that we have the same states within the assembly. So we have fine, medium, and coarse. And note down on the left hand side we've got our standard browser with all of the components within it. If I turn the model, we can see that we have some gears that are internal to this assembly. Now changing to the fine model state updates the assembly. We go to the medium, it updates the assembly, and each of the components in the assembly is changed to its medium state. We'll see some of the components are kept, the shaft, the coupling, they are pretty simple as is, so they are kept as normal. And the internal components have been suppressed. If we go to coarse, we will see the same process happen there. And so the model states here are being used to not only simplify the model, but also remove geometry that may be specific intellectual properties, like the internal gearing on this component. And so that is one way in which you can control the complexity of components and assemblies, is using that model state. Now going back to the presentation, we're going to look at an option called Simplify. Now, Simplify is a tool built into Inventor that allows you to remove geometry in a much easier way than manually going and suppressing features. Simplify allows you to remove details such as fillets and chamfers quite quickly, but it also allows you to pick surfaces to then create voids that can be filled. So we see here in the middle image at the top, we have essentially patched surfaces that have then created that void in the center to be filled, as well as the fillets and chamfers have been removed from this casing. And then it also has the option to define envelopes. And this is a process where you do not need to create a sketch and an extrusion. You drag a box or snap a box to the correct size, and it then defines that envelope for you. So Simplify can be used at part level to simplify components down. Throughout the Simplify process, features are added to your model browser. So you have those simplified features that are added, and this can be used in conjunction with model states as well. I'm going to go ahead here and have a look also at Simplify at assembly level. Slightly different at assembly level. Simplify View allows you to create a view representation where components have been included or excluded from the view. So Simplify View, as I said, creates a new view representation with components that are removed or included. This helps when we move on to the Simplify process that allows us to create substitutes, which we will see a little bit later on. Simplifying the assembly also allows you to define envelopes which are created as assembly features. So here we can see on the right hand side we have some of the components that have been excluded. You'll note there in the lever there's the large sort of flywheel that's been removed, as well as the shaft and the coupling inside of that lever, and any internal components removed as well. And once again, at assembly level, we've got envelopes defined around the gearbox housing to show the space requirement for the housing. Then moving on, still within the Simplify arena, we have the option to create a simplified part. So what this will do is we'll take the assembly as is. So whether you have a state active in the assembly that reduces the quality of the geometry, or whether you have a view representation active that removes components, you can create a simplified part of the assembly as it is. And essentially this extracts all of the assembly information and creates a single part file to represent that assembly geometry. We then have the create substitute option, which allows you to either replace components with envelopes. It allows you to exclude components. So we could exclude internal components from the assembly, but it also allows you to remove features such as holes, fillets, and there's a whole list more of features that can be removed. So we can see the difference between the left image and the right image, where the substitute has been created and the holes have been patched and details have been removed. And your output for the Simplify at assembly level is either to output a new part, pretty much like the create simplified part option, or it can output a substitute. There are also advanced options that allow you to fill voids, etc. We'll have a look at this within the demo. So I'm going to work through this quickly here. In the demo, I'm going to go back to a part here. So we'll see the fully featured gearbox housing. There are no states. If I want to create a simplified state, we could basically create the model state 1. You can rename it if you wish. But then on your 3D modeling tab, you will either have the simplification panel there, or if it is not there, you may need to switch it on by clicking the drop down and choosing the simplification option. But here we have 3 choices. We can remove detail. So I'm checking model state 1 is active. I'm going to select remove detail, and a little heads up display comes up and we have fillet and chamfer options to remove details for fillets and chamfers. If we choose auto select, it will select all fillets and chamfers to be removed. I'm happy with that. I want to do that for this. We'll hit apply, and that removes all the fillets and chamfers quite quickly from the design. We can also choose all faces selectable, and by selecting faces on the component, that would allow you to remove those faces. But obviously I do not want to remove these larger faces, so I'm going to go ahead and cancel that selection. That would allow you to, let's say, remove an internal face for a hole, and it would then patch or heal that. Now these features are being added in the feature tree. We'll see delete face 2 and delete face 3 being added as features. If I change back to the primary state, those features are then suppressed. Going further on, we can fill voids. And in this case here, fill voids I find quite nice because we can choose just to select faces. It will find the holes in those faces and patch them, and it creates a sculpt feature to then close off that geometry. So I'm going to do that for now. Hit accept, and it closes off all those holes and fills the voids within the part. And we can see the sculpt feature added. So these are quick and easy ways in which to simplify the model down within the part environment without having to go and manually find those features, each feature, and suppress those features or delete those features. Lastly, we do have the define envelopes option. In this case here, I'm going to define 2 envelopes. The first one being a bounding box. We'll select the underside of the part, and it will size the bounding box to the footprint of the gearbox. Now we can resize this bounding box because it is a little bit short, and we're going to snap the top of the bounding box to the top of the filling nut that we have there, that little sump plug. I'm going to accept that to create that bounding box, and secondly we'll create a bounding cylinder from the face of the mounting flange, and we'll resize that all the way to the back. We'll snap that to the bounding box around the housing. And then we have our defining features, or our bounding box features. So we can quite easily switch states between primary and that simplified state using and that simplified state created using the options on simplification. Now at assembly level, let me get back to this assembly here. I'm going to go back to the primary state, and at this level here we have the options as spoken about in the PowerPoint, in the presentation. We have the ability to simplify a view that will create a new view representation. So if we go to representations and view, we will see that we have default view. There's a simple view 1. So going ahead there to simplify view would allow the user to select components. I'm going to go ahead and just grab a couple of components there, and those components are going to be removed from the view. So I'll hit accept. Sorry, I had the wrong option selected there, so let me undo that. Go back to simplify, so those selected components were going to be included. You'll see there select to include. So I only want to include, let's say, those 4 components. If I hit OK here, the rest of the components are removed. It's internal components and components that are not going to affect the bounding box. And that creates a simple view. So we'll see we've got simple view 2 now as a view representation. And we can switch between the different views and remove the different components. Now this assists in helping pre-set up the model if you want to create a simplified part, because as I said, with the simplified part, it takes the assembly as is and outputs a part file that represents the geometry of the assembly. Before we do that, I would like to first define envelopes. So we go with the define envelope option, and pretty much the same as in the part environment, you're able to select an object and define an envelope. Now in this case, we're selecting the part, and it creates an envelope for the entire part. Now this may not be desirable, but this envelope is resizable. So as I did with the single part itself, I can actually resize the envelope. And what I'm going to do here is I'm going to keep the original, set that to show original, and hit apply. So the original part is still showing, which allows for me to then create a second envelope, which is a cylindrical envelope, which can be resized to the cylindrical part of the design. So I'm going to go ahead quickly and snap all of the dimensions to the model, and now I'll choose to hide the original, and the gearbox housing is removed, and we have these envelopes as features inside of the assembly. So it allows you to then simplify down assembly components or components within an assembly and the assembly itself, hide certain components, and you can go to the last step, create simplified part here, which would take the assembly as is and output a part file. So here we're outputting a standard part file into the datasets location. We'll hit OK there, and the part file is then opened. So we could share that part file or send that part file on to somebody. You'll see that this part file is a derived part. So we do have the derived feature in the feature tree. You can suppress or break the link with the base component, with the assembly, if need be. Now that is a multi-step process for simplifying using the three options individually: simplify view, define envelopes, or create simplified parts. But what we can also do, if I go ahead and change this back to its standard configuration, we can also just use the simplify command. The simplify command pretty much brings all of this into one dialog box. I have a predefined setup here that I'm going to choose, MGFX Simplify. Essentially, that has just got a couple of settings pre-set up. You will see that there are a couple of built-in ones: remove the least detail, remove moderate, or remove the most detail, and a couple of demo presets that I've got here. So I'm going to go there with MGFX Simplify, and you would work your way through the list. You can choose an input, so either a model state to simplify. You can choose a view rep, so I can go to simplify view, and it loads that view representation. Here's view 1. I'm going to go with the default. There are options here to replace with envelope. This is an automatic replacement, so you can do either the entire assembly as one envelope, each top level component as an envelope, and we don't have any sub-assemblies, so this and the next, which each part as an envelope, will look the same. So you can choose if you need to do that. I'm going to go none there. You can exclude components by size, and so this allows you to adjust by size. So let's exclude any component smaller than this large gear. You can actually use the measure and select that gear, and any component smaller than that gear, including that gear, will be removed, and you'll see it puts the size value in there. So we see 6 parts being excluded out of a total of 12. Then we can remove features. So we've got options here to remove features. We've got, let's say we want to remove holes within a range, and we can choose to measure this hole on the base, and that's 14.28. So let's say any holes smaller than 15 will be removed from the model. And I'm going to go ahead with any, let's say we remove all the fillets. There's an option to highlight that will then highlight all of the features that will be removed. You'll see that the fillet, because I chose to remove all fillets, the round on the end here is being removed, so that may not be desirable. So I'm going to go all within a range, so let's say all fillets equal to or smaller than that corner round. Let's highlight that. That looks a little bit better there. Not removing detail on the handle there. After you've set up your simplification, you can then choose your output type. So there is a type, there's the option to output a new part file, and that would be the same as what I did earlier with outputting that part. Alternatively, you can output a substitute. Now, a substitute allows you within the assembly to switch between the fully detailed assembly and a single part file that represents the assembly geometry. There is also a Revit model for those of you that need to supply to Revit users. In this case, I'm going to go with substitute, use the standard part file template. I'm going to leave the default location information here, the settings, and then we have those advanced options to be able to remove any internal parts, fill any internal voids, and I'm going to use the color override so the colors stay the same. I'll hit OK. The assembly is defeatured and the substitute is created and activated, so we can see the substitute there. This is the second substitute for the assembly, so we could switch to the other substitute. So you'll see the change in the assembly. And if you want to go to the fully featured assembly, you can go back to the primary, and that loads the full assembly. So we can see here on the bottom right, there are 12 components within that assembly. If we go to one of the substitutes, that is reduced down to 1. I have a much larger assembly here, which I have done this with as well, sort of one of those pre-baked before the show. We have this assembly, we've got currently 1,941 components within that assembly in its primary mode. And if we go to the substitute, that simplified substitute, just to have a look and show, we've got all the nuts and bolts. There's all the details within that. We've got the spline on the shaft as well. We can go activate that simplified component, and it's brought down from 1,000 odd down to 1 component within the assembly. And we can see that, if my computer will just recover here, the square tubes, all the fillets have been removed from the square tubes. We do still have some details with regards to nuts and bolts, but the bulk of the nuts and bolts have been removed. And so this assembly has been simplified down for us to be able to use a much lighter assembly in the overall scheme of things. Now, coming to the main assembly, what we'll see here in the main assembly is we're able to take that component. We'll see here that it has all of the fully featured information in it. If I zoom in here, we can see once again all the nuts and bolts. And in the main assembly, we can change the representation, and we can change it out to that simplified representation. And so the assembly goes from about 7,500 components down to about 5,600 components. And so now we have less components in the assembly. And that can be done for each of the sub-assemblies inside of this main assembly to reduce the weight and the requirements. Okay, so we're going to go back into the presentation for the summary and questions and answers. And so in summary, what we are looking at, or in summary here, what we looked at is we looked at how we can protect IP by removing geometry and filling in any internal voids. And we looked at how we can reduce the complexity of parts if you are suffering slowdown. So We can reduce complexity of parts. We can also reduce part count. So kind of twofold with the simplification processes. We are removing and protecting intellectual property, and we're able to work with the assemblies much quicker. We saw for large assemblies, we could create substitutes where those substitutes have been simplified down, as well as the use of states. Within the substitutes, we could have activated a simplified state as well to help with the process. And then when it comes to large 3D layouts, I know that this was just one small machine, but this entire machine could have been substituted out, and we could then do a large factory layout with the substituted assemblies. So that is it for the summary, just a couple of the tools that allowed us to do these things. I'd like to open up for Q&A. Feel free to post up in the live chat if you have any questions, and then I will answer those questions. I do see that Ali7 said, hello sir, will you get the full episode of the webinar on your channel? Yes, this webinar is being recorded, so the full session will be up on our YouTube channel to view in your own time. So I'm going to give it a few minutes for any questions to come through, and I'll answer those questions as they come through. Okay, we haven't had any questions come through, so I would like to thank you for your attendance, whether it was during the live broadcast of the webinar or whether you have watched it after the fact and watched the recording. I'd like to thank you, and if you do have any questions, my email address is there, carl@mgfx.co.za. It was also on the first slide of the presentation. You're more than welcome to email for any information with regards to the webinar. So once again, thank you very much. This was a webinar by Micrographics, and please, if you enjoyed this, please like and subscribe to the YouTube channel, and don't forget to click the bell for any notifications for any up and coming webinars. We also do post how-to videos or little videos showing tips and tricks within the various products, Autodesk products that we sell. So feel free to go have a look at our channel and have a browse through the channel for any other content that may interest you. We also have our website, mgfx.co.za, and if you have any other information regarding Autodesk products or even hardware, you can get hold of us at info@mgfx.co.za. Once again, thank you very much and enjoy the rest of your day.